Hello everyone, welcome to IFAS and this is Vikas. So in today's lecture we will see subspace. So first of all we will see the definition of subspace. After that we will solve few examples on the basis of subspaces. Okay. After that we will go to the two shortcut method, that is how to find the subspaces by using one step method and two step method. Okay. So let us start with the definition of subspace. Okay. So what is a subspace? Suppose V is a vector space. Suppose V is a vector space over some field F, okay? And W is a subset of V. And this W is non-empty. It means that V is a vector space, W is a subset of V which is non-empty. Then this W is said to be a subspace of V if it satisfies a certain condition. And what is that certain condition? If W forms vector space over F with the same vector addition and the scalar multiplication of V. Okay. So what is a subspace? Basically, subspace is a subset of a vector space V which is non-empty, and that subset also form a vector space over that field F with respect to the same vector addition and same scalar multiplication as that of V. Okay, clear? So next, if W is a subspace of V, so that subspace is denoted by this symbol. So this is read as a W is a subspace of V. Clear? So what is a subspace? So subspace is a non-empty subset of a vector space V, which is itself a vector space under the same vector addition and scalar multiplication of that vector space V. Clear everyone? Okay. So now next we will see few examples. So let us consider the first question, and first question is given that A1, A2 and so on up to AN, and each AI belongs to R. It means that A1, A2, A3 and so on up to AN, all entries belongs to real number. Okay. Is a vector space over a field F, and what is a field F? Field F is a set of all real number, that is R. Okay. And W is a given, and W contains set of all n tuples A1, A2 and so on up to AN, but these n tuples satisfy certain condition. So what that condition? That condition is that A1 by A2 is equals to 2. Okay. So there are four options for this question. Then which of the following is correct? So first option is given that W is a subspace of V. Second option is given that W is not a subspace of V. Option C, 0 element does not exist, and last option is none of the above. Okay. For this question we have to find out the correct option. It means that if a V is a vector space and it contains n tuples, it means that what is a V? V is Rn and W is a subset of Rn. W contain all those n tuples which satisfy the certain condition, and that condition is A1 by A2 is equals to 2. Okay. So first of all check that whether the 0 element belongs to in W or not. So what is the 0 element of vector space V? So 0 element is given by 0, 0 and so on up to 0 n tuples. This is identity, or you can say that the 0 element of the vector space V identity, or you can say that 0 element. Okay. So this is the 0 element of the vector space V. Now we have to check that whether this 0 belongs to W or not. Okay. So if what is the condition for W? Condition for W is that A1 by A2 is equals to 0. A1 by A2 is equals to 2. So what is the A1 for 0? For 0 vector A1, A2 and so on up to AN, all AIs are 0. It means that A1 by A2 is equals to 0 by 0, which is not defined. It means that 0 vector does not belongs to W. So 0 vector does not belongs to W. It means that W is not a subspace of V because it does not contain the 0 vector, or you can say that it does not contains identity element. Okay. So check one by one each option. W is a subspace of V. So this is incorrect because 0 vector does not belong to W. Okay. So what is option B? W is a subspace. W is not a subspace of V. So this is correct. Why? Because 0 vector does not belongs to W. And option C is given that 0 element does not exist. It is also correct. 0 element exists for V but does not exist for W. Okay. And last option is none of the above. So 0 element does not exist, write down for W. So this option is also correct. So here option B and C are correct and rest of the options are incorrect. Clear everyone? Okay. So next we will see next question, and next question is given that V is a set of all n tuples whose elements are say a1, a2 and so on up to an, and each ai belongs to real number. Okay, is a vector space over a field f and that field is real number, and w is a subset of v, but w is again a set of w is a subset of v, but it satisfies the certain condition, and that condition is product of first two tuples is always equals to 0. Okay, so this is the condition for w. Okay, then there are four options given that first option is given that w is a subspace of v, second option is w is not a subspace of v, third option is zero element does not exist, and last option is scalar multiplication is not closed. Okay, so first of all check that suppose if a question is asked for check whether the given space or vector space is a subspace or not. So in that case first of all check whether the zero element belongs to the set or not, vector addition is closed or not, scalar multiplication is closed or not. Okay, so first of all we will see whether zero vector belongs to this set. So 0, what is the zero vector for v? Zero vector for v is this 0 0 and so on up to 0 and times. This is the zero vector, or you can say identity element. So this is zero vector. Okay, clear? So this is zero vector. Zero vector also belongs to w. Then we check whether the w is a closed under vector addition or not. Okay, so for that first of all let x is equals to say 1 0 and so on up to 0, and product of first two tuple, that is a1 into a2 is equals to, that is 1 into 0, and this is equals to 0. It means that x belongs to w1. So this implies that x belongs to w. Also take y is equals to, y is another vector whose elements are 0 1 and so on up to 0. If you check product of a1 into a2, that is 0 into 1 is again 0. So it implies that y also belongs to w. Okay, so here two vectors, that is x and y, belongs to w. Now we want to check that whether their addition is also belongs to w or not. If their addition is also belongs to w, then it's fine. If their addition does not belongs to w, so in that case we can say that w is not a clause under vector addition. So this implies that w does not forms a vector space. Okay, clear? So this implies that, so consider x plus y. So what is x plus y? X plus y is 1 comma 0 and so on up to 0 plus 0 1 and so on up to 0. So this is equals to 1 comma 1 0 and so on up to 0, and this is equals to say a1 a2 a3 and so on up to an. Okay, now we want to check that whether x plus y is belongs to w or not. If x plus y belongs to w, so in that case product of first two tuple is equals to 0. So what is the product of first two tuple for in this case? So this is the first tuple and this is second tuple, and product of these two tuples is equals to 1, which is not equals to 0. So this implies that x plus y does not belongs to w. X plus y does not belongs to w. It means that w is not a subspace of v, because vector addition fails in w. Okay, so correct option for this question is, so write down the correct option for w is a subspace of v, so it is incorrect. And second option is w is not a subspace of v, so it is also correct. Third option is given that zero element does not exist. For this this subspace w zero element exists, so this is also incorrect. And last option is scalar multiplication is not a closed. So this is a homework for you. Please check it whether this option is correct or not. For that you have to check whether alpha dot, if x belongs to w, then alpha dot x is also belongs to w or not. Okay, clear everyone? So if you check, this option is also incorrect. Okay, so for this question only one option is correct, that is option B. Clear everyone? Okay, so now we will move on next slide. So after that we will see few results, or you can say subspace test, that is one step test and two step test. By using this subspace test we can easily verify whether the given space is a subspace or not. So there are two tests. One is one step test and second is two step test. In one step test we can verify in one step whether the given given space is a subspace or not. or in a two-step test. In two-step we can verify. Okay, so what is a one-step test? So suppose V is a vector space over a field F. So V over F is a vector space, and again W is a subset of V, and W is non-empty. Okay, so what is the W? W is a subset of V, and this W is non-empty. Then W is a subspace of V if and only if. So if and only if alpha x plus beta y belongs to W, where alpha beta belongs to field. It means that alpha beta is a scalar. Okay, and xy belongs to W. It means that xy is a vector and alpha beta is a scalar. So one step test is saying that suppose V is a vector space, W is a non-empty subset of V, then W is a subspace of V if and only if alpha x plus beta y also belongs to W, whenever alpha, for every alpha beta belongs to field and xy belongs to W. If a certain subset of W satisfy this condition, so in that case we can say that the W is a subspace of V. So in this step, in this test, we can verify whether the given subset is a subspace or not in one step. That's why this test is said to be one step test. Okay, so this is a one step test. So now we will see two step test. Okay, so two step test is saying that suppose V is a vector space over a field F. Okay, and W is a subset of V. W is a subset of V. W is also W is non-empty. Okay, then W is subspace of V if and only if is satisfy the two condition. So what are the condition? So first condition is that for every x comma y belongs to W, then their addition is also belongs to W. So it implies that, so first condition implies that W is a closed under vector addition. Okay, and what is the second condition? Second condition is saying that for every alpha belongs to field, it means for every scalar and any x belongs to W, then their product, that is alpha dot x, is also belongs to W. And this that is a statement 2 is saying that W is a closed under vector addition. Okay, so in short we can say that by using two step test, a non-empty subset of a vector space is a subspace if and only if it is a closed under vector addition, and second, it is a closed under scalar multiplication. Okay, so a non-empty subset of V which is a closed under vector addition as well as scalar multiplication is called as a subspace of a given vector space V. Okay, and what is in one step test given that? In one step test given that alpha x plus beta y belongs to W. So here alpha x plus beta y, it means it is addition alpha x plus beta y, and if we multiply alpha with x, it means it is a scalar multiplication. So in one step test, vector addition as well as scalar multiplication apply in only one step. Basically these two tests are same. If any subset of V is a subspace, then you can easily verify by either step 1 or step 2. In both the cases you will get subspace. Okay, so these are the two tests by using which we have to decide whether the given subset of a vector space is a subspace or not. Clear? Okay, so next we will do one question on the basis of this subspace test. Okay, so next question is given that which of the following are subspace of the vector space over vector space of R3. Okay, clear? So in this case we want to find out the which of the following options are the subspace of R3. Okay, suppose this is W1 and this is W2, this is W3 and this is W4. Okay, for these options we want to check that whether which Wi is a subspace or which Wi is not a subspace of V, that is R3, by using subspace test. Clear everyone? So let us start with the first option, that is option A. Option A is given that W1 is equals to XYZ such that X plus Y is equals to 0. Okay, so first is given that W1. So what is W1? W1 is equals to and W1 is equals to X, Y, Z such that X plus Y is equals to 0. Okay, so this is the W1 and we want to check that whether the W1 is a subspace of V or not. Okay, so first of all consider check whether the W is a non-empty, because first condition for checking the subspace, first of all check that whether the given set is non-empty or not. If we check 0 vector, that is 0 0 0, belongs to W1 because it satisfies the condition for W1. So it belongs to W1. So this implies that W1 is non-empty. Okay, clear? So after that we will apply for one step test or two step test for using for checking the whether the W1 is subspace or not. So we will check it by two step test. If you want, you can also check it by one step test. Okay, so by using two step test, so first of all let x comma y, x is equals to say x y z, and say y is equals to x dash y dash and z dash belongs to W1. Okay, so here given that x and y belongs to W1, if x and y belongs to W1, it means that x and y satisfy the condition for W1. So this implies that x plus y is equals to 0 and x dash plus y dash is equals to 0. Okay, clear? Now we want to show that x plus y belongs to W1. That is, what is x plus y? X plus y is equals to x plus x dash, y plus y dash and z plus z dash. Okay, for this problem, so that addition of first two tuple is equals to 0. It means addition of this and this is equals to 0. So we have to show that x plus x dash plus y dash is equals to 0. If we show this, then the first condition hold. Okay, so start with LHS and show that LHS is equals to RHS. It means LHS equals to 0. So consider. So what is LHS? LHS is equals to x plus x dash plus y dash. So I can write it as x plus y and x dash plus y dash. But here x plus y is equals to 0 and x dash plus y dash is equals to 0. It means this is equals to 0. So this implies that x plus y belongs to W1. So first condition here satisfy. Okay, now we check second condition, that is a scalar multiplication. Here we shown that W1 is a closed under vector addition. Next we want to show that W is a closed under scalar multiplication. Okay, so second so that alpha dot x belongs to W1, where x is equals to x y z, which belongs to W1. If x y z belongs to W1, so it satisfies the condition for W1. So this implies that x plus y is equals to 0. Actually we want to show that alpha into x is equals to 0. So what is alpha into x? Alpha into x is equals to alpha into x y z. So this is equals to alpha x alpha y alpha z. Okay, for this problem we want to show that alpha into x belongs to W1. It means we have to show that addition of these two tuples is equals to 0. Okay, so consider alpha x plus alpha y. So take alpha as a common. So this is equals to alpha times x plus y. So this is equals to, but what is x plus y? X plus y is equals to 0. So alpha into 0 is equals to 0. So finally we show that alpha into x is also belongs to W1. So here we show that if W1 is a subset of V and it is a closed, and W1 is non-empty as well as closed under vector addition and scalar multiplication. So this implies that W1, therefore you can say that W1 is subspace of V. Okay, so this implies that W1 is a subspace of V. So check the option. First option is given that what is the question, which of the following are subspace of vector space R3? So we shown that this is a subspace of V, that is W1 is a subspace of V. Similarly you can show W2 is also subspace of V. Here option A and B are correct. Okay, so I did for option A and option B is a homework for you. Okay, so what about option C? Option C is given that W3 contains all three tuples such that x plus y is equals to 0. Okay, so first of all check that whether the identity element belongs to W3 or not. for option C. Okay. So what is the identity element for V? So V is R3. So for R3 identity element, or you can say that zero element is 0 comma 0 comma 0. So what is the zero vector? Zero vector is 0 comma 0 comma 0. So we have to check that whether this zero vector belongs to C or not. This zero vector belongs to C only if satisfy this condition. So this is X, this is Y, and what is the addition of X plus Y? So this is X, Y and Z, and what is the addition plus of X plus Y? So X plus Y is equals to 0, which is not equals to 1. So this implies that zero vector does not belongs to W3. So zero vector does not belongs to W3. It means that W3 is not a subspace of V. So W3 is not a subspace of V. V means R3. Okay. So option 3 is incorrect. Option C is incorrect. Okay. So what about option D? For option D, what is option D? Option D is given that set of all three tuples which satisfy this condition. First of all, we will check whether zero vector belongs or not. What do you think? Zero vector belongs? So what is the zero vector? Zero vector is equals to 0 comma 0 comma 0, and zero vector does not belongs to 0 comma 0. Subtraction of first two tuple, that is 0 minus 0 is equals to 0, which is not equals to 1. So this implies that zero vector does not belongs to W4. So therefore we can say that therefore W4 is not a subspace of V. Subspace of V, it means W4 is not a subspace of R3. Clear? So for this question there is only two options correct, that is option A and B, and option C and D are incorrect. Okay, clear? So this is the definition of subspace, and we saw few results, that is a one step test and two step on the basis of subspace, and we did some problem. Okay, so in today's lecture we will stop here. So thank you so much for joining us and happy learning.